The hot inlet temperature, that one would be 250 degrees Celsius. The fluid is going in, cool it down. Again, we're going to be using water. The mass flow rate for the cold fluid is 1 kilogram per second. And your cold inlet temperature is going to start at 35 degrees Celsius. Have you ever feel our tap water, what sort of temperature it is? 10. And you got a refrigerator tap. Normally it's about around a little bit lesser than 30 degrees Celsius. A little bit lesser. Depending on where is that water coming from, if you have a water tank right at the top of the building, this tank tends to get heated up in the late afternoon. So if you go back home, like after heat transfer class, then go back home, rush the tap water, turn it on, and feel the temperature is kind of like a little bit warm. So 35 degrees Celsius, yeah, that's pretty warm already. And these are just about all the conditions that are given. You have your UH, again equal to 100 watt per meter squared Kelvin. AH, given as 40 meters squared. So the question actually wants to find out what then is the heat exchanging, the rate of heat transfer. It wants to find out what is Q. Also, it wants to find out what is your outlet water and gas temperature. So this T, H, O, and this T, C, O. Wants to find out these two things. So the properties remains unchanged from the last example, so I'm not going to rewrite them. So please refer to them. I'm going to calculate, first of all, to find out which one will be my C mean. So I have my CC is equal to M dot C. CC equal to 1 kilogram per second multiplied by the specific heat capacity 4197. For the CH, M dot H, CH equal to 1.5 multiplied by the specific heat capacity, that's 1000, that's given in the previous question actually. So do the calculation for both of them, 4197, and the other one will be 1500. And ask yourself which one is your C mean. CH is a C mean, so I'm going to write it here. So the other one will be the C max. So let's find out what is CR. CR equal to C mean divided by C max. So C mean here is 1500 divided by 4197. Do that calculation, 0.357. So with that, we can actually start to figure out what is the number of transfer units, which is UH AH divided by C min. And you kind of have all these variables with you already. This is 100. Right, yeah. I could hear. So this AH is 40 over C mean, that is 1500. Okay, work it out, you get 2.67. So now that you have your CR and NTU, or number of transfer unit, again, we're going to go back to our graphs to try to find out what is my epsilon. So from the graphs above, do your best interpolation. Tell me what's your value. It's still going to be on this graph using the NTU that's equal to 2.67, right? And a CR that's 0.357. What is your epsilon, your effective number? .82 as one of the number. Anyone else? Everyone got 0.82. You share the same eye. All good? 0.82? Correct. So that means if I see 0.83 from someone, I'm not going to take that. 83, okay. So around that region, I wouldn't expect it to be very different. If you have 0.8, it's kind of like stretching it already. I gotta go back and have a look where possibly you could have made a mistake. Now, SSA try. Try that on this graph. What is your epsilon? Try it on this. That is 0 point. Get it 0.8. What? 3, 4, yeah? Around there. So it's kind of hard to tell, but some of the graphs I would know that if you read it from the wrong graph. So because I can't check, are you reading from the correct graph or not? So the value that you get, if it's too far off, then I'll look at the graph. No way. 0.8. No, you're by yourself. So you'll get less amount of that. Okay, so try to read as accurately as you could. That's why last year your seniors did the calculation way. No way to make mistakes, and you get very accurate epsilon value or NTU value. So this year is reading from graph. So I'm allowing a little bit of margin of error. Okay, let's have a look at the rest of this question. So now I heard 0.82, so I would accept that one. And the next thing I want to find out is that Qmax, since I had epsilon already. So you know where I'm getting to. After Qmax, later on I'll be looking for Q. So that's equal to C mean multiplied by THI minus TCI. That will be 1,500 multiplied by the temperature difference. That will be 250 minus 35. That will give you 3.23 times 10 to the power 5 watts. So you guess it, after Q, that's equal to epsilon multiplied by Qmax. So that will be 0.82 multiplied by 3.23 times 10 to the power 5. So work it out, you'll get that as 2.65 times 10 to the power 5 watts. That is my Q, and Q refers to my heat transfer rate, or a heat exchanger, under that set of flow rate, specific heat capacity conditions. So because Q is also equal to mass flow rate for a hot fluid, specific heat capacity, THI minus TH naught. I could readjust that formula to get me the TH naught as a subject. That will be equal to THI minus Q divided by m dot HCH, because I'm after the outlet temperature. So put in all those numbers, 250 minus Q, I haven't calculated Q, yeah, I have it. Q over here is 2.65 times 10 to the power 5 divided by this m dot HCH. That will be what you have calculated at the top, 1,500. Bring you over there. This one is calculated already. So that's 1500. Do that calculation, you get that as 73.3 degrees Celsius. Now some students ask, that 73.3 degrees Celsius, can it be 73.3 Kelvin? What do you think? Actually, it cannot be because you use your THI in degrees Celsius. So you can't have 73.3 Kelvin. So the last part of it, because we know that your Q is also equal to mass flow rate C, Cc, T, C naught minus Tci. So I could re-express this to find out what is my Tc naught as a subject. Tci plus Q over m dot C, Cc. That's equal to 35 plus 2.65 again, divided by your mass flow rate multiplied by your specific heat capacity for the cold fluid. And in fact, you had already solved that. That's right up here. Already solved that. That's right up here. So I'm gonna just write it in 4197. Solve that one. That's 98.1 degrees Celsius. So that kind of wrap up your heat exchanger topics. I believe I've uploaded the tutorial questions. You could attempt that. So some of you were asking, are there going to be any discussion for tutorial? Normally I want you to get the opportunity to practice it first. And then when it comes to revision, because most of you actually start practicing it during your revision period. So during that time, class rep, class rep, please take the sentiments of everyone, which day you prefer to have your consultation with. Okay? About 2 hours consultation. So what it means is I come in with concepts that you want to ask. Don't come in to ask what is in the exam. There's no answer. All the exam data. Okay? Any hint for exam, account for the exam is in the exam. So I actually plan to use this time to talk about your review